Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video examines the different levels of measurement in statistical data. Let's get started. In previous videos, we classified data as being either quantitative or categorical. And if the data were quantitative, we classified them further as either discrete or continuous. Now we're going to talk about another way to classify the data with levels of measurement. We have 4 types of levels of measurement: nominal, ordinal, interval, and ratio. Let's take a look at each one of these 4 types so we can better understand the differences between them. First up, we have nominal data. Nominal data have 2 defining characteristics. The first is that they consist of names, labels, or categories only. That means nominal data are always categorical data. The second characteristic is that they cannot be arranged in any sort of ordering scheme. Here's a good example: a survey with possible responses being agree, disagree, or not sure. Agree, disagree, and not sure are certainly names, labels, or categories, but there's no obvious order to how you would arrange them. There's no one way to arrange them that is inherently better than any other. That's a key characteristic of nominal data. Next at bat is the ordinal level of measurement. Ordinal data have 2 defining characteristics. The first is that they can be arranged in some natural order. This differs from nominal data, which cannot be arranged in a preferred order. And second, the differences between data values in ordinal data either cannot be determined or have no meaning. Now, here's a good example of ordinal data: a set of letter grades, say A's, B's, C's, D's, and F's. The group of students who receive the grades is immaterial. The letter grades are letters from the English alphabet and so represent categories with a natural order. Notice that the data values represent different categories, making ordinal data categorical data. But the differences between data values are something you can't determine. Let's suppose we're using a standard grading scale in which 90% and above is an A, 80% to 89% inclusive is a B, and so forth. Well, if all you have is the letter grade, what's the real difference between an A and a B? Let's say that A is a 95 and the B is an 85. In that case, the difference between the A and the B is 10 percentage points. But what if that B is an 80? That's entirely possible, and that would make the difference between the A and the B 15 percentage points. Or what if the A is really a 90 instead of a 95? Because these data values are categorical data, you can't determine the exact difference between the data values. You must have quantitative data to do that. And ordinal data are categorical data. Just having a letter grade alone doesn't do it. So to recap, ordinal data are categorical data that can be arranged in some natural order, but the differences between the categories either cannot be determined or are meaningless. Next, we have interval data. Interval data have 3 defining characteristics. First, we can arrange the data in some natural order. In that respect, interval data is like ordinal data. However, unlike ordinal data, the differences between interval data values are meaningful. Finally, interval data have no natural zero point. A natural zero point would be a point at which none of the quantity measured is present. Years are the classic example of interval data. Say we have a data set of the years in which some specific type of event occurred. Because each year is a number, we can arrange them in a natural order from lowest to highest, or highest to lowest if you prefer. Differences between data values are meaningful. Hello, There's a world of difference between 1895 and 1970, right? I mean, one has air conditioning, refrigerators, and indoor plumbing, and the other, well, okay, hang on here. Actually, the wealthy were starting to put indoor plumbing in their homes in 1895, so we can't really put that on the list. But you get the idea. The point is that there is a definite difference between data values when they are years. Notice that because differences between data values are meaningful, interval data are quantitative data. Finally, as we use them in Western society, years have no natural 0 point. The year 0 is not conveying a sense that time is not existent. It's just an arbitrary standard. The year 0 is assigned to when Christ, the deity of the traditional religion of Western civilization for many centuries, was born. So it's not like year 0 means there's no quantity of year or time. It's just a point at which convention resets the counter. So to recap, interval data is quantitative data that can be arranged in some natural order, have differences between data values that are meaningful, and have no natural data 0 point. Finally, we have ratio data. Ratio data also have 3 defining characteristics. First is that, like interval data, they can be arranged in some order. Second, also like interval data, the differences between individual ratio data values are meaningful. So far, ratio data are neck and neck with interval data, but here's where the two diverge. With ratio data, there is a natural 0 point. With interval data, there isn't. Now, here's a good example of ratio data. A sample of speed measurements. Your speedometer displays all sorts of different possible data values. These different values can be arranged in some natural order. And the differences between data values are meaningful. I mean, there's a big difference between 60 miles per hour and 25 miles per hour. Finally, there is a natural 0 point. A data value of 0 here means you're not moving because you have 0 speed. Notice that even with this final distinction from interval data, ratio data are also quantitative data. So this is ratio data. Quantitative data that can be arranged in some natural order, have meaningful differences between individual values, and have a natural 0 point. Let's review the main differences between the 4 different levels of measurement which we just learned. Nominal data and ordinal data are both categorical data, but nominal data cannot be arranged into any natural order, whereas ordinal data can. But neither nominal data nor ordinal data have meaningful differences between individual data values, and they don't have any natural 0 point. That's because they're categorical data. On the other hand, interval data and ratio data are quantitative data, and because of that, they both can be arranged in a natural order and have meaningful differences between individual data values. But interval data have no natural 0 point, whereas ratio data do. You may want to pause the video here and make a note of this table, because in the next mini lecture video, we're going to play a game in which having this table will prove very useful. And that brings us to the end of this mini lecture. I hope you found it helpful. As I just mentioned, you'll find some practice with this topic in the next mini lecture. And as always, you can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.